Hi everyone and welcome to Algebra 2, lesson 2.6. Alright, so we're going to start looking at the standard form and vertex form again of parabolas. So let's just talk about a little bit of algebra review first. So we're going to look at perfect square trinomials. So a trinomial of the form ax squared plus bx plus c, alright, where the b term divided by 2 squared is going to equal a times c. Right? So basically what that means is if you have a 4 here, okay, if we divide it by 2 and square it, it's going to equal 4. Okay, and that should equal the a times c. So if this was 1 and this was 4, that would be fine. All right, it's just a small little algebra review thing. So we're going to start looking at some factoring techniques again. And so we're going to factor the following trinomials. Now this x squared plus 8x plus 16. Right? Before you even think about the fact that it's a perfect square trinomial, when we factor things, and we're talking about when the leading coefficient, right? This is a 1. Works like this. We think of two numbers that are the factors of 16. So 16 could be 1 times 16, could be 2 times 8, could be 4 times 4. And vice versa. You know, it can go backwards and forwards. They all equal 16. Now, what we're looking for is, because this is a positive, that means that both signs are the same. So either they're all positive or all negative. So positive 1 times positive 16, positive 2 times positive 8, positive 4 times positive 4. Or negative and negative. Now, how do we know which one to use? Well, when we multiply our two factors, they should equal 16, but when we add them together, they should equal the middle term, which is a positive 8. So this tells me that they're both the same sign. Okay? And this tells me that that sign is positive. Right, so that means I need two numbers that multiply to 16 to add to be 8. So 4 times 4 is 16, right? And 4 plus 4 is 8. So these are our numbers we're using, is a 4 and a 4. So when we factor this, this winds up being x plus 4 plus x plus 4 times x plus 4. And the reason this is called a perfect square trinomial is because when you multiply anything, like 2 times 2 is the same as 2 squared, or x times x equals x squared. Well, because x plus 4 and x plus 4 are the same, we could say that this is just x plus 4 squared. Right? And this pattern exists anytime we look at these kind of things where we have a perfect square here and a perfect square there. All right, because 1 technically is a perfect square. All right, so now let's look at this next one, m squared minus 18 squared plus 81. So 81 is a perfect square, okay? And so when I look at 81, 81 equals 9 times 9. Now, this tells me that their signs are the same, and they're both going to be negative. So that means I have negative 9 plus a negative 9, and that does equal negative 18, which is right in the middle. So this one would just be x minus 9, which winds up being x minus 9 squared. Right? And this pattern exists, that all we're doing, that if this is a perfect square, and this is a perfect square because it's 1, all we're going to do is just write whatever the square root of this last term is and use this sign. So as long as this is positive. So like this one, the square root of 1 is 1. So we go x plus 1 squared. The square root of 25 is 5. So I have x5, and you see this is negative, so this will be negative squared. I'm sorry, it should be a p. And this should be a. I'm bad with the letters sometimes. This should be m. All right, so let's move on to standard form. So if the standard form equation is a perfect square, like example 1, which is what we just did, simply factor to convert to vertex form. If not, you can use a process called completing the square to write in vertex form. Now remember, the vertex form, that was that, remember the a times x minus h squared plus k, right? So we can find the vertex where the vertex is h and k. Remember, add to x, go left, add to y, go high. So what we need to do is we need to move stuff from standard form to vertex form by completing the square. All right, so the way we complete the square, so if the first term a, this one right here, is not equal to 1, we have to factor it outside so it becomes basically equal to 1. And then we have to complete the square. So we take half of b and we square it, and what we're going to do is we're going to add that to both sides. So the way this works is, and write this down because I don't like these instructions. Step 1. Divide. Helps if I can spell divide. Divide the b term by 2. Step 2. Square the result. So whatever number you get, you're going to square it. And then, step 3, add it to both sides. Okay, so those are your steps. Step 1, divide b by 2. Step 2, square that number. And step 3, add it to both sides. All right, so let me clean this up so I can show you what I'm talking about. So when we look at number 1 is in standard form. I can't tell what the vertex is unless I go through an entire process of doing, the negative b over 2a and then plugging that number in to find y. It's a process. But what I can do is complete the square. By number 1, I'm going to take the b term. So this is a, b, and c. So in this case, a is 1, b is 4, and c is 4, okay? And I'm going to complete the square. The way I complete the square is I take my b term, which is this one, so b equals 4, and I'm going to divide it by 2, which gets me 2. Then I'm going to take this number, and I'm going to square it, giving me 4. Now, once I have 4, what I'm then going to do is I'm going to rewrite my equation. So my original equation was x plus 2 plus 4x. Now, you see there was a 4 here originally. Whatever was originally there, it doesn't matter. I'm going to give it some space and write it right there, leaving some area in the middle. All right? And now that I have some area in the middle, I'm going to take whatever my answer was, and I'm going to pop it right in that space that I made. But the rule is, whatever I do to one side, I have to do to the other. So I have to add 4 on the right side as well. Okay? So now, once I've gone ahead and I've done that, I can now move this into what's called vertex form. Right, so now to move this in vertex form, okay, so my standard equation in vertex was this, but remember, it always equals 0, right? These are always equaling 0, but over here, I can see that my new equation equals a positive 4, right? And even if I write this a little neater, what I'm having here is I had an x squared plus 4x, my new 4x, my new 4, let's put this in purple, plus 4, and my original one was plus 4. And since I added 4 on the left side, I have to add 4 on the right side. But what I'm going to do is that new one that I did, I'm going to put that in parentheses. And this 4 that existed already, I'm going to move it over to get rid of it so that all that's left is this. But when I do that, this cancels out and becomes 0. So what I'm left with now is x squared plus 4x plus 4 equals 0, which is exactly what we had before. And this is a horrible example to look at when we do this. Now, all we have to do now is factor this. We see that this is a perfect square, so this is going to become x plus 2 squared. So our final thing is f of x equals x plus 2 squared. So because we're adding to 2, our vertex is going to be a negative 2, 0, because we have nothing being added into it. All right, I'm going to go ahead and do number 2 to kind of clear it up, because number 1 was a bad example, the way they gave it to us. So I'm going to take my b term, and I'm going to cut it in half. Negative 8 divided by 2 is a negative 4. Then I'm going to take my negative 4 and I'm going to square it, which gives me 16. So what I'm going to do is I'm going to take my original equation, x squared minus 8x, and I'm going to leave a little space for this this 16 that I'm putting there. And what I'm going to do is I'm going to write that in a different ink color. So now I'm going to add 16 there. But since I did it on the left side, I have to do it on the right side. All right, this is standard completing the square. All right. Now, technically, what's going to happen here is I can go ahead and I can factor this. When I factor that, okay, this 16, which is 8 times 8, this is going to become x plus 8. Oops, x minus 8, because this is negative right here. X minus 8 squared. Now, I still have this plus 18 and plus 16. But remember, I said everything has to equal 0, okay? So this 16 is on this side, so I'm going to minus 16. Okay? And when I do that, I get x minus 8 squared plus 2, technically equals 0. Now, this is the vertex form of my parabola. So I have a negative 8, so that gives me a positive 8 for my vertex. And I have a 2, which gives me 2 up. So that is the vertex of my parabola. Okay, on to number 3. So number 3 is a little unique because we have this negative sign. And we need to pull this negative sign out. The way we pull this negative sign out is we are just going to change the signs of everything. So meaning that I go ahead and I pull that negative sign away. So that negative x becomes x squared. My positive 6x becomes negative 6x. And my negative 5 becomes positive 5. And now we follow our same process. So b is 6, or negative 6 divided by 2 is negative 3. And when we square a negative 3, we get a 9. So that's what we're dealing with. So now when we write this out, we have a negative x squared minus 6x plus 9 plus 5. All right? And now what about the other side? Well, you notice the other side, I can't go ahead and add 9 like I did on the other one. So I just add it to the other side. And the reason is that that 9 is trapped in those parentheses. So imagine if I were to move this 9 outside of the parentheses, it would have to change its sign back to negative 9. Right? Because basically it's only a positive 9 because I factored out this negative sign here. So what happens is if I move it out, it's negative 9. So this would be a negative 9 on this side. So just remember that when you have this negative sign in front, you're doing the opposite on the other side. Because when you think about it, that's what the negative sign means. So now I need to go ahead and factor this out, because this is our perfect square. And notice, whatever we're using here, that's the number that is being factored. So now I have a negative x minus 3 squared, right? There is our minus 3. And now notice that technically this is all in another set of parentheses, and this plus 5 is still kind of hanging out there. But I don't want it in there, I want it away. So what I'm going to do is I'm going to have my negative x minus 3 squared, and I'm going to move my 5 outside, which makes that a negative 5 equals negative 9. And then when I add my 9 to both sides, I get a negative x minus 3 squared plus 4 equals 0, which makes my vertex now a 3, 4. All right, that's how you handle the negative sign. All right, let's look at number 4. Number 4, okay, the big thing is that my leading coefficient is not 1. So that could be an issue. All right? So what I'm going to do is I need to factor out that 2. And the way I factor out that 2 is I just take the two things I really care about, the a and b, and I'm going to divide 2 out of both of them. So I'm basically just dividing by 2. So this gives me a 2 in front, all right, and an x squared minus 6. And that positive 13 is still there. All right. Now, I'm going to go ahead and take my b term, which is the 6, and I'm going to divide it by 2, which gets me 3, and square it, which gets me 9. All right. So now I have 2 x squared minus 6x plus 9 equals 13. Now, the thing that we have to remember, okay, is I can't add 9 on this side again, because where is the 9 that I put in? The 9 I put in is inside. And in order to move outside, I kind of have to do whatever is going on right here. So like this one was change the sign. This one, to move it outside, okay, I would have to multiply it by 2, giving it 18. So really, this is just going to be a positive 18. All right, because that is how it looks when it's outside its parentheses. All right, so now the next thing I'm going to do is I'm going to factor this, and I see that I had a 3 here, and this is negative, so it should be negative 3. So that'll be x minus 3 squared plus 13 equals 18. When I minus 18, I get 2 x minus 3 squared minus 5 equals 0. So that puts my vertex, okay, at a 3, negative 5. All right, so we're going to move on to number 8, where we notice that there is a 4 in front. So when there is a 4 in front, we just have to factor out the 4. So if I factor out my 4, 4x divided by 4x squared divided by 4 is just x squared. And then that negative 8 divided by 4 is going to be 2x, right? So it's just kind of factored out like that. Now that I have that, I can go ahead and start completing the square. I see that my b term is a negative 2. So negative 2 divided by 2 is a negative 1. And then when I have negative 1 squared, that is equal to 1. So basically, what I have is a 4 x squared minus 2x plus 1 equals, well, 1. I mean, well, it would equal 1, but what happens is we have to multiply everything by 4. Okay, so basically this is just going to be a 4. All right, so this 4 here affects everything. All right, so now that I have that, I can complete my square. So 4, and then this factors into, well, see how this is a 1 right here, and that's negative? So x minus 1 squared equals 4, and then we have to move our 4 over, which gives us 4 x minus 1 squared minus 4. And that is our equation. Right, now we make our vertex 1, negative 4. All right, let's go ahead and try 9. So for number 9, what I'm doing is I have to factor out this negative 2. So when I factor out a negative 2 here, right, I'm only going to factor it out of this. The 46 is fine by itself. When I take negative 2x divided by negative 2, that gives me an x squared. 20 divided by negative 2 is a negative 10 x. So now that I have this, I can go ahead and I know that my b term is negative 10. So I divide it by 2, which gives me negative 5. And when I square negative 5, it gives me a positive 25. All right, so now I have a negative 2 x squared minus 10x plus 25 minus 46. Now, what about on the other side of the equal sign? Well, technically, I have to if I move this on this side, this should be a negative 50 because negative 2 times positive 25 is a negative 50. So that's what goes on the other side. You have to account for that. Now I can factor this. I have a negative 2, and see how this equaled negative 5? That's what's going to go here. X minus 5 squared minus 46 equals a negative 50. And now I add 50 to both sides, which gives me negative 2 x minus 5 squared plus 4. My vertex is now 5, 4. All right, let's go on to number 10 and try that one. So number 10, I have to multiply. All right, so basically I have to factor out this half is what's happening. So when I factor out a half, or negative a half, this just becomes x squared. Now negative 4 divided by negative a half is positive 8x. Okay, when you think about it, negative 4 divided by negative a half. When you divide with a fraction, remember this is 4 over 1, you flip the second fraction. So this really comes up here to be multiplying negative 2 over 1. So this will just be 8 over 1, which is 8. So that's why you get your 8x, and you have your minus 5. So now, when I take my b term, b equals 8. 8 divided by 2. All right, sorry I had to pause this for a second, so I think I remember where I was. All right, so that's how we got our 8x, right? So now, yeah, all right, this is where we are. B equals 8 divided by 2, which is 4, and 4 squared is 16. So that's our 16 right there. So now we have a negative 1/2 x squared plus 8x plus 16 minus 5. Now remember, on the other side, right, if this was going to be a positive 16, if it can't, to get it outside of our parentheses, if it lived outside, it would have to be multiplied by negative a half. All right? So that negative a half gets me negative 8. So now when I factor this, I have 1/2. This 4 that was here is going to be our answer. So x plus 4 squared minus 5 equals a negative 8. And then I add 8 to both sides to get it by itself. So I have negative 1/2 x plus 4 squared plus 3 is going to be my answer on that one. Right? And that makes my vertex negative 4, negative 3. Sorry if that one got kind of screwed up because I had to pause it because a student needed help. All right. Moving on a little bit. This says convert to vertex form, identify the vertex axis of symmetry, then graph. So vertex form, we're going to complete the square again. Right? We're going to take negative 12 and divide it by 2, getting us negative 6, and square it, getting us positive 36. So x squared minus 12x plus 36 plus 39 equals 36. We have to put this 36 on both sides. Right? We can go ahead and we can factor that. X, see I had a negative 6 here? That goes right here, squared, plus 36, plus 39, equals 36. When I minus 36, x minus 6 squared plus 3 equals 0. So my vertex is going to be 6, 3. And now I can go 5 and 4 and 7 and 8, and I just start plugging them in. So if I want to go 4, if I get my table of values here, right, this is x squared minus 12x plus 39. When I go ahead and I put a 5 in here, 5 squared minus 12 times 5 plus 39, 25 minus 60, right? That's negative 35 plus 39. Well, that's going to be 4. So 5, 4. When I put the 4 in, this gives me 4 squared minus 12 times 4 plus 39. Well, 16 minus 48, so that's a negative 36, plus 39, well, that's going to get me a 3. But wait. Bad arithmetic. 16 minus 48, that's negative 32, plus 39 is 7. So that'll be a 7. And these will be the same, 4 and 7. All right, so now I can go ahead and graph this. I have 6, 3, 5, 4, 4, 7, right? Same thing on the other side. 7, 4, 8, 7. So this is like my parabola that looks like this. My axis of symmetry, right, is 6. Axis of symmetry. The vertex is 6, 3. And then we graphed it. All right, and I'll let you guys do number 12.